Good morning all. Here we have the I/O board for a Kuhnke PLC. And the PLC model number is 140.656.00. You also see a .01, the same board though. And the complaint with this board right here is one of the outputs, the driven outputs, is not working, and we don't know which one. If we were over at the machine, which we don't have here in the shop, of course we could figure out by troubleshooting which output's not working, and then we'd know which IC to change. There's 24 outputs, and there's a driver IC for each output. These LEDs right here indicate which output is turned on. This is the 3 connectors right here. So these 8 driver ICs go to these 8 outputs right here on this connector. The second row of 8 go to this connector right here. And the last row of 8 go to this connector right here. This connector right here with the plus and the 0 sign, that's your 24 volts DC input to power up these driver ICs. They're fused, and we have a protection diode right here that prevents, that protects the board if the power gets connected backwards. So the cathode is across the plus, and the anode goes to the minus. Since we don't know which output is bad, we're going to have to figure that out. Now these 3 connectors right here are for digital inputs. This connector right here is for analog output. These 2 connectors here on the end are for analog input. Now, I've got this circuit over here kind of mapped out, and I could put those up at the end of the video if you ever have to troubleshoot your analog section. So, how do we figure out which IC is bad? I put my meter into resistive mode, and we're going to put our red lead on the 0, which is this anode, the 0 input, that's your ground input, 24 volt ground. I'm going to put our red lead here, and then we'll probe all of the inputs with the black lead, and they should all be the same. If we see a difference, we're going to zoom in on that, because that's going to be the one that's bad. Then we'll put our black lead on the cathode and do the same thing. And if we find a difference, that's the one. So here, let's put our meter into resistive mode. Let's see, how can I get all this into the screen so you can see it, what's going on. Let me do that. Give me a minute. I'll be back. Are we in the screen? I got these metal bars over here on the side of the board to keep it from wobbling around while I'm probing on this. Let me turn this light on. Can y'all see that okay? Okay, so red lead on the anode. That goes to the 0 pin right here. Red lead on the anode of that diode. Okay, we charged up a cap. There's little caps right here. Let's do that again. We charged up that cap, then it went to overload, OL. They should all do that if that's good. OL, OL, OL. You can see we're charging up a cap there. OL, 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 OL. So far, all of these outputs are the same. There's OL. We're on the second connector. OL, 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 OL. Okay, those 2 output connectors are the same. Let's go to the last one. Well, now look at this. There's 746K, 0.746 meg. That's different. That should go to OL, but it didn't. Let's check the last ones. OL, 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 OL. Let's go back to this one. 746K. That is probably the bad one because all of the other ones were OL except for that one right there. Now let's put our black lead on the cathode. That goes to the plus input on this connector. Am I in the way? Okay. Oops. I've got to get that black lead out of the way of the meter. Okay, there we go. Now let's see what we got here. Black lead on the cathode, red lead on the input. 377K, 377K, 377K. It looks like they should all be around 377K. 378K. I'm reading this upside down. 377K. I had to turn my brain upside down. 377K. 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 All of those 377K. Let's go to the second connector. 376K. 377K ohms, kilo ohms. 377K. 377K, so far so good. 377K. 377K. 378K. 378K. This is the different one. The first pin on the third connector. Let's see what it measures like. Ah, look at that. 322K. It's different. That's the one we got to change to fix this top board. Let's check the last ones. 377K. 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 378K. Okay, let's find out where this pin goes to. Let's see. I put the beep on. Beep, beep, where are you? Beep, there you are. Looking at my meter upside down. Let's see where this one goes to. Probably goes to this one right here. Yep, there's the output pin on that TDE 1898. There it is. This is the one we have to change. I'm going to mark it so if I turn my head I don't forget which one it is. Let's put a little X on there. Okay, thank you, meter. You did a good job. Now we'll change out that IC right there and we'll put this Kuhnke PLC back together and it can go back into the machine and she can do a little bit more work. Back in a little bit. We're going to use this chip quick to remove that IC from the board. This is good for removing surface mount ICs. It stays molten long enough to where you can remove that device. Okay, I'm going to put some flux here on the board. Come on. just flux the pins. Let's get us a stick of chip quick out here. Okay. Get my close-up glasses on so I can see what I'm doing. Take my hat off so it don't get in the way. There we go, we're ready. Oh, tweezers. Gotta get all my tools here. Come here, tweezers. Time to go to work. Okay, that's one side. Let's get the other side. Look at that. Come loose really quick. There we are. Now we'll take our solder wick and clean up the board. Let's put a little flux on that solder wick. I think we're ready to install the new IC. Okay, let me get my surface mount solder. Okay, we'll set an anchor point right here. Put my overhead light on. Let's see. Okay, there we go. Now I can see. Kind of dark here in the shop. Get all kinds of light, but it just never shines where you need it. Okay, there's our new IC. Don't put it in backwards, people. Okay, I'll try not to. Is my head out of the way? Can y'all see? Okay, we got that anchored in. Everybody lined up. Looks good. And it's not backwards. That's the most important thing. It can be a little bit offline, but as long as it's not backwards. Let's start soldering on this side. Okay. That side's good. Let me flip the board around. And we'll get the other side. Okay, don't melt that connector. There we go. Okay, I'll look at it with a magnifying glass. Make sure I didn't miss anything. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. That side's good. I flip around and check the other side. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. That side looks good. Okay. I'll clean up the board and we'll put the Kuhnke PLC back together. All right, let's put the Kuhnke back together. This is the control board. And here's the SRAM backup battery. I don't like the way they did this. They got the battery in the very bottom of the board where you have to take the whole thing apart to change the battery. And the battery will always, it will invariably leak onto the board and eat up these traces down here. And then you have problems with your board because of open traces. Very, very bad design. Other than that, this is a fantastic system. Here's your flash, and this is your EEPROMs, and you have some gals over here. Over here are 3 state connectors that connect the I/O board to the control board, and the control board to the I/O board. And on the bottom of the I/O board are the 3 connectors that mate to those state connectors. So I always have a problem. It's so funny because I can solder fine pitch ICs like that surface mount IC that we just did, but I have a hard time lining up these connectors to the state connector. I always have a problem. My fine motor skills are not so fine anymore, so we're going to try and get these guys all lined up, and I might get it on the first try. Maybe. Come on. Oh, we're so close. Okay, who's holding this up here? Let me get my close-up glasses on again. Probably should put my headlight on. So, okay. Ah, hey, I got it on the second try. Unbelievable. Oh, I forgot to put something in. Doggone it. Got it on the second try. So all of these connectors down here are 24 volt ground, and all of these connectors right here are 24 volt in. And the ground and the 24 volt in plus 24 volt is for the I/O on the top board. And there's a stake connector over here that connects this 24 volt to the 24 volt power supply. So you got to get this stake connector in right here. Now, okay, let's do this 10 more times, trying to get those stake connectors lined up. Here we go. Uh-oh. Let's get this put on here. Are you in? Come on, hands. Go to work. Okay, let's try it again. One of the stake connectors came up a little bit. I gotta even it out with the others. Push it back in. There we go. Okay, it's even with the others now. Okay, we got those two in. Now for the hard side here. Okay. Come on. Okay, I think we're in. Okay, it looks like we're all in. Okay, now to secure the top board to the 24-volt input. Standoff. The standoff is for the lid. You have to put this all together before you set it into the housing. This one goes here. These two screws, they go right here. That one and this one. Okay, now we can set it into the housing. Don't forget the insulators. They insulate the bottom board from the back plate. There's grooves in the wall that these boards have to set into. There we go. Now we got that all seated. We can flip it over and install the screws that hold the control board and I/O board to the plate. There's one. Let me dump these out so I can get my fingers on them. Almost there. Slotted, tiny slotted screws. They could have used Phillips screws here, but they had to make my life difficult. Okay. All right, there's one. This is my physical therapy for my weak left hand. I'm left-handed too, but after my stroke, my left hand got wiped out. Had to go to physical therapy for a little bit, and 2 and some odd years on, I'm still in physical therapy for my left hand. Oh, jeez. Come on. Come on. There you go. Are you in? Okay. So that one. That one. That one. All right. We're all back together. Now we're going to power it up, and you get to see how these LEDs look when they come up. Now, this connector says, the middle connector says 24V. Both those pins are the 24. That's 24. That powers up the control and supplies 24 volt for the I/O. And then we have 0V down here on the bottom connector, and that's where we apply ground to the 24 volt supply, and it supplies ground for the I/O. This connector again is for powering up those outputs on the top board. So let's hook our connectors up here. Okay, we're going to put 24 on the red wire and ground on the black wire. Let's get the camera closer to those LED. Excuse me, closer to those LEDs, and you can see how they look when this thing powers up. Okay, here we go. Okay, this is the way it always comes up here in the shop. Well, there you go, folks. Hope you enjoyed that video. That was a grizzly bear. Not the hardest thing we've worked on here, but not the easiest either. Okay. I hope that helps you if you ever have to troubleshoot one of these Kuhnke's. Thanks for coming over and seeing what we're doing next.